So in my last video, I have explained here SN1 and SN2 reaction. In my today's video, I will explain when the reaction will be favorable for SN1 and SN2 with respect to the primary, secondary and tertiary alkyl halide. Here you have here primary alkyl halide. This is primary alkyl halide. So here in this case primary alkyl halide, this is primary carbon. So here the reaction would be always what SN2. So SN2 reaction would be favorable when the alkyl halide is primary. Suppose say you have a tertiary alkyl halide, which is say like CH3, CH3, CH3 and say Br. Now over here this carbon is tertiary carbon. So this in this reaction this will be favorable for this compound. It will be always SN1 favorable. SN1 favorable. Okay. Now why it is so? Why this one will always favor SN1? Because in case of SN1 reaction, as an intermediate, there is what is produced is carbonium ion. So I will explain here as carbonium ion formed. Now here this carbonium ion is stable. Okay. So when it is a tertiary carbonium ion, that tertiary carbonium ion is favorable. I'll just show you here. Suppose say we have here, as I have explained in the earlier video, the reactions I have explained. So suppose say we have here Br. Now this will undergo slow ionization. There will be slow ionization. And as a result of this, this will produce a carbonium ion which will be say like this, CH3 and say CH3. Okay, and this is say carbonium ion produced. Carbonium ion carry positive charge. So here this is a waste structure which I am trying to explain. Okay, carbonium ion form. Now carbonium ion means positive charge. Then Br is out. So Br minus is out. So ionization has taken place. Now what happened? The nucleophile will add here in two ways. One is OH minus, suppose I take here nucleophile adds OH minus aqueous. Then this nucleophile can add to this compound or to this carbonium ion in two ways. One will be like this. Just understand this. I will explain to you this way so that you can understand what is formed here. Last time I think I have explained in my video. So again I will just recollect that CH3 with OH over here. Okay. So OH is to the right. The second possibility is having the same compound but the addition of OH is to the left. Okay. So suppose say we have here, I'll just show you the same way here as the waste structure. So this is how you get the thing, say CH3. Okay, and here OH is added. Okay, now this is say 50%, and this will be also 50%. All right. So this will lead to what is called a racemic mixture. I have explained to you that, and therefore SN1 reaction always give you racemization. Because 50% of the OH group to the right and 50% OH group to the left. As a result of this one will rotate the plane of plane polarized light to the right. This one will rotate the plane of plane polarized light to the left. And therefore this mixture will be optically inactive. And therefore this is called as racemic mixture. And this is known as racemization. So in SN1 reaction, there is racemization taking place. Okay. And why it is so? Because the carbonium ion formed here has a planar structure. This is plane. So in the plane of the board, suppose, then OH can add here, OH can add this side also, both the side possible. and as a result, this will be racemic mixture. Now, if it is, suppose say tertiary carbon or tertiary alkyl halide, the carbonium formed is found to be stable, and because it is stable, therefore, always tertiary compound will undergo SN1 reaction faster. Okay, so please note that properly. So tertiary will always favor which one? SN1. So remember this. Now, if it is say primary will always favor what? SN2. Now why it is so? So remember this also. Why? I'll explain to you.